Okay, so let's see how to make a half adder in VHDL using structural style of modeling. So since we are using structural style of modeling, we'll also have to create the components of a half adder first. As we know that the equation for sum of a half adder is A XOR B, and for carry it's A and B. So we'll be needing an XOR gate and also an AND gate. So first let's create those. So let's add a source, add a design source, create file. Let's call it and21 and make sure to choose the language over here as VHDL. Okay, finish. So now this asks us for all the ports we want in our design. So as we know, for AND we have 4 ports, 2 inputs A and B, and also outputs sum and CARY carry. Sorry, as this is the AND gate, we only have 3 ports A, B and output Y. This is out. Okay, so let's click on OK. And as we can see, our file has been added over here. Let's click on this. Okay, so for AND gate, we know that the output of AND gate is just AND of both the inputs, so A and B. Yeah, so it's done. So that's done. Now let's also create an XOR gate. So again, add a source, create design, next create file, XOR21 VHDL. Okay, finish. Also same A, B, Y, output. Okay, this is also created, and the equation for this is just Y A XOR B. This isn't actually very complex, but we are having to make this because we have to make the half adder using structural style of modeling. If that wasn't the case, we could have only just used these equations in the half adder code itself. But now, as the XOR gate and the AND gate is ready, also create the half adder. So add a source, create design source, next create file. Let's call it HA VHDL. Okay, finish. Ports would be A, B, sum and carry. Let's make these okay. So the half adder is created. So now, since this is structural style of modeling, what we'll be doing over here, okay, we can also call it this use struct, but it's just the name, so it doesn't matter. So we'll have to declare both of these as components in our new code. So we'll just copy it from here. Control V. Same for the XOR. And we'll make this a component. Comp to any component. Okay, so now as we have added both of them as components, what we can do is map them to the ports of our half adder. So how you do that is Q1, this is just a label, then component name and Q1 port map. And so for the AND gate, we'll map inputs A and B, and the output of the AND gate is carry, so sum carry C, and U2 XOR to 1 port map A, B and sum. So now this code is also ready. So how do we see if it's actually working? So for that we have to create a simulation source. So you can click on add sources, create an add or create a simulation source, the third option. Next, create a file, VHDL HATB test bench. So test bench को create file, finish. In the test bench code, we don't have to add any ports. So we'll just click OK. And as you can see, it's created over here. So now in this, we'll declare our half adder as a component. So we'll just copy the entity from here. So we have declared the half adder as a component. Now what we can do is we'll just have to supply inputs to the ports of this half adder, and let's see what the outputs are produced. So for that, let's first declare some signals. Signal A, B, sum and carry as standard logic. And what we can do is first let's just map all these signals to the ports of the HA. So U1 port map HA port map A, B, sum and carry. So let's just check this out. So what we can do is first let's create a process. Begin, and for start let's give 1 on A on the A and a 0 for B. Then let's wait for, let's say, 100 nanoseconds. Then also check a few more cases where we give a 1 1 and also a 0 0, and then end the process. Let's see the file. So after you have created that simulation source, you have to make sure that it is set as top. So it's already set as top for this, but if it isn't, you can click over here and set it as top. And if it is set as top, you can just click run simulation, run behavioral simulation. So let's just close this. So over here we can see that when the input for this is A is 1 and B is 0, the sum is 1 and the carry is 0. When both of them are 1, the sum is 1 and the carry is the sum is 0 and the carry is 1. And when both of them are 0, sum is also 0 and the carry is also 0. So it means that our half adder is working properly. So after that, you can also implement this design by clicking on run implementation, map this to the ports of any FPGA board, and also generate bit stream and then upload it to the FPGA board as well. But for that, you also have to just make sure that when you are uploading to a board, just like when over here in simulation sources this was set as top, this should be set as top. So this is also set as top by default, but if this isn't set as top, the implementation will be run for the AND or the XOR, and that will produce a wrong output.